Okay, I just wanted to record a couple examples about, today we talked about even and odd functions. And so an even function is a function and I would say like such that f of x or f of negative x is equal to f of x for all x in the domain. And then we have a similar statement for odd functions. An odd function is a function such that f of negative x is equal to negative f of x for all x in the domain. Okay, and we took a look at a couple of pictures of this, but for example, a pretty common even function is just a quadratic that has not been shifted, let's say, to the left or right. So f of x is equal to like x squared plus 2. Maybe that's what this is. And a pretty typical odd function is the cubic function that maybe looks like this. F of x equals x cubed, right? And these power functions, x squared and x cubed, are the original kind of meaning behind this even and odd, that power functions that are even are also even functions or have even degree, and then power functions that have odd degree, oh, I don't want that, are odd functions and have odd symmetry. So I just want to say, like, I think that y'all can evaluate these visually, but we also want to, we did a couple in class about to try and prove this algebraically. So let me see. I'm going to do a couple. So let's say f of x is equal to, and then we'll do 1 over x cubed. And the question is, say whether f of x is even, odd, or neither is the classification scheme. Okay? And provide a reason. Okay, so when I want to solve this problem, I want to go ahead and kind of do the following steps. One, both of these, even and odd, involve the function f of negative x. And so one of the first things I do is just plug in negative x into f of x. Okay? So now, when I say plug in negative x, I don't mean plug in a negative number. So one of the things I just want to catch us right now is some of y'all were plugging in, let's say, f of negative 4, and you would figure out what that is. So let's say this is 1 over negative 4 cubed. And then 4 cubed should be 64, and then negative cubed is 1 over 64, right? And then you would show that f of 4 is 1 over 4 cubed, and this is 1 over 64. And so you would notice that f of negative 4 is negative, the negative value of f of 4, and so you would say that it's odd. And I'm going to say this here doesn't show f of x is odd. It only shows that -4, the value at -4 is the opposite value, or the negative of the value of f of 4. It only shows you something at 4 and -4. And if we go back up to this definition, we really need to show this for all x in the domain. And the reality is it's not that much different to show this for all x. So I want to just give it a couple examples of how to do that. So I'm going to plug -x into f of x. So here's my function. So I'm going to take f of x, and everywhere, in this case, here is the place. Oh, almighty, that's not a highlighter, strangely. So here is the place. I think maybe green is a highlighter. Okay, good. So here's the place where I want to plug in -x. So I do that. So I have, what is it? 1 over, and then I'm going to get -x cubed. So this should feel exactly the same as when I plugged in over here in a -4, right? Okay. And then I'm going to simplify this. Simplify. So this is f of, and this is -x. So f of -x is equal to, and then I really want to simplify this piece right here with the cubed. So this is -1 cubed will give me a negative overall here, and then I'll just get x cubed. Because I have a -x, this, I just want to remind you, this is -x times -x times -x, right? And so that overall value will be negative, and then I'll have 3 x's. So that's negative and then an x cubed. Okay. So, so now usually what people do, sometimes what you can do then, if you're not sure, is to just list again the functions that f of x is equal to 1 over x cubed. Now I am pretty sure that these are not the same function. Do you see? I'm doing a comparison of this one, number 1, and this number 2. And these are definitely not equal to each other. Okay, and so then I might write down f of x and the negative of it, right? Because that's the one that I have to compare for odd. So -f of x is -1 over x cubed. And I remember that this negative can either move to the top or to the bottom. And so these, when I compare 1 with 3, these are equal. Equal functions. Because they're equal, that means it's odd, right? When f of -x is equal to -f of x, this is an odd function. So so the final steps, how many steps do we have? 1, 2, here, this 3 is compare. Like compare f of -x with f of x and -f of x. 4. Write your conclusion. Since f of -x is equal to -f of x, this is odd. Done. Okay? Okay. So let's do this second problem, or second example. And so I'll have g of x is equal to x over x squared minus 1. And again, I want to figure out if this is even, odd, or neither. So I'm going to go ahead and find g of -x. And I'm going to plug in x, -x, everywhere I had x. So in the numerator, I get a -x. In the denominator, I get a -x, and then that is squared and minus 1. Okay? And then I'm going to simplify. So this is, in the top is just -x, and I can take off the parentheses. In the bottom, this piece here is -x times -x, right? So this is a negative times a negative. It should be positive overall, and then I have 2 x's, so x squared minus 1. Okay. Now I need to do this comparison. So g of x, sometimes I don't bother writing this because it's right up here. Do you see that? So I'll just look and look back instead of rewriting it, but I might write it here just so that we can, I don't know, look at it in two places. That seems redundant. So here we are, and again, when I'm observing them, there's definitely no way that these are equal because I have this negative here and I can't really move it or get rid of it. Now negative g of x is again negative x over x squared minus 1. And this is the same. Again, this moving of the negative, I can move it up into the numerator. So conclusion, since f of negative x is equal to negative f of x. Oh, this is g of x, though, is the name of my function. So let's use the right name. The function is odd. Okay, one more. Let's do this last example. H of t is equal to absolute value of t cubed, right? So again, I'm going to find, maybe now using the negative h, negative, I want to do it like this, negative t, and that value is cubed. Okay, so then I'm going to work out, when I cube negative t, I know this is the third time I've done this, and you're really thinking to yourself, I don't need to see this again. But I have 3 negatives, so I get a negative and then 3 t's, right? Now, negative t cubed, I'm trying to figure out, and maybe I'll write the comparisons over here. This right now definitely does not look the same as this one. And this one, negative h of t is a negative t cubed. So it doesn't look like either of these, but the question is it really equal to either of them, and can I do something about this negative to make it equal? Okay, so one question is, does the negative just pull out of the absolute value? That is not true, because right now what's on the right side of my equation is definitely a positive number right here, right? So the reality is, if I take t and cube it and it becomes negative, when I pull it out, that's the same thing as just t cubed. That this negative inside on one kind of value or one expression will not change the actual sign of this result. So now these two lines here are equal because of that reasoning, and then that is the same thing as h of t. So since h of negative t equal to h of t, then h of t is even. Okay, so I hope this is a little bit helpful, and I'm going to give you some homework on this, so let me know if you have questions.